With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So here we have a question. We have two statements. First statement says that let n is less than or equals to 3, a1, a2, a3, so on, an be n independent events such that pak given by 1 over k plus 1 for k less than equals to n and greater than equals to 1, then p a complement intersection a2 complement intersection a3 complement intersection and so on equals to 1 over n plus 1. And my statement 2 says that let a1, a2, a3 up to an be n less than equals to 3 event associated with the random experiments, then a1, a2, a3, an are independent if pa1, a2 and so on equals to pa1, pa2, pa3 and so on. Okay, and we have 4 options. Okay, these are the 4 options. So I'm going to check which option is correct. I'm going to solve the question. So here, first of all, I'm talking about statement 2. So my statement 2 is correct. Okay, my statement 2 is correct. How? Let me tell you. If we have two events, let's say event A and event B, okay, both are independent to each other, then their probability, or we can say the intersection of probability of the intersection, can be given as PA times PB. Hope you already know this basic thing. This is the basic definition for the independent event. Okay, so this is what we already know for the two events. Now here you can see there are n events from 1 to n. There are n events. So for n events, I can multiply probability of a1, probability of a2, and so on up to n. So yeah, this statement is correct. Now by using the second statement, I can solve for the first statement. But here we wish to find out the probability of a complement intersection, a2 complement intersection, and so on. So we have to find first complement. Okay, so we know the probability of ak is given by 1 over k plus 1. It is given to me in the question, as you can see here. Yeah, you can see here. Okay, now as you already know how to find the complement of a probability. Okay, so I'm going to find the complement of a k. It is nothing but 1 minus the probability of a k. Okay, so it will be probability of a k bar will be given by 1 minus 1 over k plus 1, and on taking LCM I can write the probability for a k bar, and it is nothing but k over k plus 1. Okay, so this is the probability for a k bar. Now for a1 intersection a2 intersection a3, here you can see I'm going to put the values of k. So I'm going to put the values. So from k is nothing but from n to 1. Okay, it is given to me in the question. Okay, it is given to me in the question, you can see here. Now I'm going to put the values one by one. So on putting 1 here, I will get p of, I'm putting k left and right both side. Okay, so I will get p a1 bar intersection a2 bar intersection a3 bar intersection and so on intersection an bar. It is given by, it can be given by p of a1 bar, p of a2 bar and so on p of an bar. How can I write this? I can write this by this statement 2. As I already told you, it is true for the independent event, and question statement 1 is also said that it is independent event. Okay, so I can write the intersection in the product form. Okay, now here I'm going to put the values. So a1 bar, for a1 bar I can put here 1, so it will be 1 over 2 only, 2 over 3, 3 over 4, 4 over 5 and so on. Okay, and finally it will be n over n plus 1. Okay, now if you can see here, this 2 will cancel out, this 2, this 3 will cancel out this 3, 4 will cancel out 4, and so on. This L will cancel out finally, but this n plus 1 remains. So I can write P of A1 bar intersection A2 bar intersection A3 bar intersection and so on An bar, it will be equals to 1 over n plus 1 only, because all the term will cancel out and 1 over n plus 1 will remains as it is. Okay, so this is the final answer. So as you can see here in the statement 1, that is what we have given. So our statement 2 is correct, and statement 2 is the correct explanation for the statement 1. So yeah, my option 1 is absolutely correct. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.